Roller coasters. They're fun, they're scary, but best of all, they're science in action. And today we're getting the chance to learn more about them from Malcolm. He's working with a physicist to combine roller coaster VR with physics education. But today he's here for some real-world thrill-seeking. Malcolm, I'm so excited to be here at a theme park to talk science with you, and this is your topic of choice, right?
It is.
But can you tell me why we actually seek out thrilling rides like that, scary things?
Well, I think it's because in society nowadays we live in a very, very safe world. It's not like when we were cavemen and we were being chased by bears and every day we were just trying to survive. But it seems that we still have that need for that thrill, that need to stay on edge. And these thrill rides, which give us these crazy sensations of going upside down, of accelerating really fast, which you can't get safely anywhere else. It seems the rides can satisfy that need for us.
All right, and we're not just here to talk about the thrill, we're also here to talk about the physics, so shall we go and check out some rides now?
I think we should.
Let's do it. Malcolm, this ride looks thrilling and a lot of fun, but could you explain some of the physics involved in something like this?
Sure. Well, probably one of the easiest ways to do it is to compare thrill rides to playground rides. Because a lot of the same forces are at work, and in Batwing here, which is basically straight up and down, you can compare it to a trampoline.
On a trampoline, you feel really heavy at the bottom and really light at the top, which is the same feeling you get at the top and bottom of a ride like this. The difference, which we're about to feel for ourselves, is this ride pushes you much faster than gravity. Time to feel those forces for ourselves. Playground physics are at play here.
Okay, you could probably compare this ride best to the swing. So when you were a kid, you wanted to go over the top on the swing, but you couldn't get enough centripetal force on your own. And also the chain or the rope, it would just buckle. But this ride has very strong arms and is powered by a motor, so it can get enough centripetal force to get you over the top and around and around and around again and again and again.
Well, that's everyone's dream, isn't it?
It sure is.
This is much more fun than any swing I've ever been on. Next! So we've saved the biggest, scariest ride for last. What sort of forces are going to be at play while we're riding this?
Well, the roller coaster brings all those forces together and more. And it's interesting that when you are going up the big hill on a roller coaster, you're building up what's called potential energy, which is all the potential energy in the ride. So the higher you go, the more potential energy you have. And then when you go over that hill, it converts to kinetic energy. And then you pretty much just twist and turn. And the important part about that hill is that it's big enough to get the roller coaster through to the end, or to its next launch, or its next hill.
So that looks really scary, but is it safe?
It's very safe. I mean, the thing about thrill rides is that they need to present themselves as being super scary and challenging, because you wouldn't take a picture of yourself on a merry-go-round to put on social media for your friends. So they appear to be scary and dangerous, but in actual fact, they're incredibly safe.
They give you some bragging rights.
They do
Well,
that too.
I'm quite nervous, but if you say it's safe, let's give it a go.
Let's do it.
The only motorised part of a roller coaster ride is the first hill or launch, used to build up momentum to get the roller coaster through the rest of the ride when gravity takes over. It's not actually the velocity or speed of these rides that's so thrilling to us. It's the feeling you get with the sudden change in speed or direction. That roller coaster was epic. And you can even ride it backwards, which means while everyone else is being pushed back in their seats, you're being pushed forward and vice versa. It also changes your perception of the ride. So unlike the people facing forwards who can see where the bends and twists are, you don't know what's coming, which adds to the shock factor or puke potential.